So recording's on. I'm going to kill my video just so that you don't have to look at me. So the topic today is verifiable credentials using Aca-py, which is the Aries Cloudagent Python, which is the agent that you guys are looking to use for the ISED banking proof of concept. If you guys, I don't have too much information specifically about the proof of concept today. I was just going to go more into general background, but if you guys want to jump in at any point to the specifics around the proof of concept that you're building, just let me know. So I've got just some general links. When people kind of out there in the community say, oh, we're interested in verifiable credentials and what's happening with verifiable credentials, these are the links that we usually give people. The first two links are edX courses that were developed by Stephen Curran. The first one is a general course around verifiable credentials and self-sovereign identity, specifically with Hyperledger, Aries, and Indy. But it provides a lot of general background about verifiable credentials as well. And then the second one, becoming a Hyperledger Aries developer, goes into more technical detail around the Aries Cloudagent Python and what's involved in being a developer. So these two edX courses go into a lot more detail than I'm going to go into today. More detail than you need to do your proof of concept, but if it's topics that you're interested in, then these are probably the two most informative links that you can go to. The BC Gov Digital Trust is information about a lot of the stuff that the BC Gov is doing. It's got links to some of the projects that the Digital Trust Services team is working on, as well as just description about some of the background of some of the projects. There's applications and I guess what you might call infrastructure projects. Aca-py kind of falls in the infrastructure. It's a generic Aries agent, and we'll talk about what that means. But then a lot of the other stuff that is listed on this site is kind of builds on top of that. And then Aries specifically, Hyperledger Aries is built using a bunch of standards, and all the standards are community developed using RFCs. So if you're interested in getting into any technical details about the actual Aries protocols, then the Aries RFCs is the site to go for. The two main directories in here are features and concepts. And like it sounds, concepts is just general concepts, like what's a protocol, what's an agent, and so forth. And then the features are the actual things that, the actual protocols that agents need to implement in order to be able to be called Aries agents and be able to interoperate with each other. So for example, there's protocols here around issuing credentials and presenting proofs, which are two of the key protocols. So if you're interested in like what are kind of the nuts and bolts of Aries and how does Aries work and how do Aries agents interoperate with each other, then the RFCs are a good place to go. Generally, I find that you go to the RFCs when you need to clarify some detail about how the protocol is working. You don't generally need to go through and read all the RFCs in order to understand Aries. You just kind of work with whatever agent you're working with, like Aca-py, and then if you're curious about some protocol detail, then you can reference the RFCs and see how the protocol is actually defined. And then specifically some of the repositories that we're going to be working with today, there's the Aries Cloudagent Python, which is the Aries agent that we're working with. And then a couple of services that you will need if you're going to be running things locally. There's a service called Von Network, which is an Indy ledger, like a blockchain, but not a blockchain. And Indy's tail server, which is related to a revocation, which we'll talk about kind of towards the end of the session today. And if you're interested in anything that BC Gov is working on, a lot of the stuff that we're working on is open source and is contributed under the Hyperledger Foundation, so it's under GitHub under Hyperledger, but a lot of the stuff that we're doing is just under BCGov. And if you go into the BCGov GitHub repo and you just want to search for Aries or Indy, then you can see a lot of the projects that BCGov is working on or has worked on. There's quite a lot. We've been working on this for probably about 4 years now, and so we've done quite a lot of demos. So a lot of the projects that are under here are demos that aren't necessarily supported anymore, but you can see just based on like how recently stuff has been updated, you can see what's current and what's not. Anyways, lots of interesting stuff if you're interested in what BCGov is all about. BCGov, by the way, is probably one of the key contributors in the world for Hyperledger Aries. So it's useful to see kind of what BCGov is working on. So any questions or comments so far? Okay, so what is a verifiable credential? Like I said, I just wanted to kind of go back to brass tacks here. Hyperledger Indy, Hyperledger Aries are all about verifiable credentials, which are digitally signed documents. Documents are issued by an issuer, they're held by a holder, and then they can present it to a verifier. These are kind of the three roles: issuer, holder, and verifier. So for example, BCGov is an issuer because typically we issue credentials. You're issuing, for example, an organization credential or an organization relationship credential. It'll be held by an individual who is the owner of that organization and can be presented to a verifier, for example, a bank, if the holder wanted to prove that they were the owner of that organization. They're the owner of the organization, so they can open a bank account under the name of that organization, and then the bank or the verifier can verify that they have a credential that was issued by BC government. So how that works, there's kind of a standard model that people look at. We'll look at the conceptual model. And this is kind of how the flow works at a very high level. There's an issuer, a holder, and a verifier, and these are the interactions that take place. The issuer issues to the holder, and then the holder interacts with the verifier in order to present their information. There's no integration or connection directly between the verifier and the issuer. So this is what makes verifiable credentials this is what makes them attractive from a privacy point of view, is that you can issue credentials to somebody and then they can use them without any ability for the issuer to track who's using the credential or what they're using it for, or for different verifiers to kind of collude and kind of get an overall picture of the holder based on different transactions that the holder is making across different verifiers. Not to say that that can't happen, but just the flow, the interaction directly between the issuer and the holder and the verifier make it much more difficult to track data or to build profiles of holders based on their data. So it's decentralized, and the holders hold their own information. There's no central database that is used as part of these transactions. The verification is supported by a verifiable data registry, or in our case, we use a Hyperledger Indy ledger or blockchain. And the way it works is that the issuer has to register public keys, essentially. Any public keys that they have need to be registered on the registry, and then the verifier can look up that information and use it to verify the credential that's being presented by the holder. So it's not, so the verifiers need to understand how to look up data on the registry, and they need to understand how to interpret the credentials, but there's no direct integration between the issuer and the verifier. And that's probably one of the key points of the whole verifiable credential infrastructure. Any questions about that? So verifiable credentials are designed for security and privacy. The holder can decide what they want to present. So the verifier will ask them for information, and then the holder will see what the question is, and then they can decide whether or not they want to present it. So because the holder's in charge, it's called self-sovereign. So they're in charge of their their data, self-sovereign identity. There's a couple of different standards of verifiable credentials. We use AnonCreds, which is the credential is supported by Hyperledger Indy. There's also a W3C standard, which is based on JSON-LD. It's got some advantages. The JSON-LD are a little bit more structured, but they don't have a lot of the same privacy features in terms of how the presentation is handled and some of the privacy features that are available in the presentation. So that's why we typically use the AnonCreds. I mean, they're kind of lacking from a structure point of view, but they've got better privacy features. So from a trade-off point of view, we tend to use the AnonCreds credentials. Aca-py supports both. You know, if you decide you want to get into the W3C credentials, you can do that. But and other agents also support them, but you won't get the same kind of privacy features that you get with the Indy credentials. So AnonCreds, so as I was mentioning, there has to be information published publicly in order for verifiable credentials to be verifiable. So the issuer publishes a DID or a decentralized identifier. If you're not familiar with decentralized identifiers, it's another W3C standard. And it's just a way of publishing what's kind of a combination of a public key as well as some metadata about that public key. And the most important piece of metadata that we use is the endpoint for the agent. So if you know the DID for an agent or for an issuer, for example, if you know the public DID, then you can use that to look up information about that issuer on the public ledger. And most importantly, you can look up their endpoint and you can use that to initiate communication with that agent. It's also the public DID that's used for signing any credentials that are issued. So if you know the public DID, then you can verify that credentials came from that organization that controls that DID. And then for a credential, there's 3 other pieces of information. There's a schema. The schema just really identifies the structure of the credential, which is for AnonCreds is just a list of attributes. It's not, there's not a lot of structure to it other than, you know, a credential is going to contain this set of attributes and this set of attributes has to be present in the credential. And then people who are consuming credentials based on that schema need to kind of understand what that data means. The schema can be published by anyone. It doesn't have to be published by the issuer. And this is so that if you've got different organizations that are publishing, for example, an organization credential, if Ontario, Alberta, Quebec, and BC are all publishing organization credentials, you can have one, you know, kind of standards organization that publishes the schema, and then everyone can publish credentials based on that same schema. So you can get consistency between credentials across different issuers just by referencing the same schema. The issuer has to publish a credential definition, and the credential definition is really a link between the issuer's decentralized identifier and the schema. And it's also a form of a public key. It is a fairly complicated document, but basically it provides public key signing information for each of the attributes in the credential as well as the credential overall. So when a verifier is verifying a credential, they look up the DID for the issuer and they look up the credential definition for the credential that's being presented. And currently they're published on an Indy ledger. I mentioned there's another one. The third piece of information is related to revocation. So I'm going to talk about revocation at the end, just to try and keep the discussion about credentials more straightforward. And then at the end, we can see all the different aspects that revocation kind of layers on to the topic. So a verifiable credential is issued by an issuer and held in a holder's wallet. I put wallet in quotes because a lot of the times when people talk about mobile agents, they call them wallets. It's just kind of a term that's out there that people use. Traditionally, with Hyperledger Indy, that we called the storage, the backend storage, we called it the wallet. So you might hear that an agent has a wallet or an agent is a wallet. Depending on the context, wallet could mean it's a mobile application, or wallet could mean that it's the backend storage that's used by an Aries agent. And then the last part of credentials, the non-credentials credentials, is that when the holder is presenting credentials, they don't show the credential directly. They show the verifier what we call a credential presentation, or sometimes it's called a proof. And what a credential presentation is assembled, it can be assembled from multiple credentials from different issuers, and it can contain a subset of the attributes that are in the credentials, and it can also include zero-knowledge proofs, which is proving that you have a credential, but without actually revealing the value of the attribute within that credential. And the common use case that we talk about with zero-knowledge proofs is if you go into a bar and you want to order a drink and you want to prove that you're over 19, you don't need to show the bartender your driver's license with your address and birth date on it. You just need to prove that you're over 19. And so that's really what a zero-knowledge proof is. The request says, prove to me that you're over 19 based on some government-issued credential, and then the holder can provide that proof. So the credential presentation is really where a lot of the value comes in a non-creds credentials. The W3C or JSON-LD are much, they've got, I guess, more structure to the credentials, but they have less capabilities of the credential presentation. Any questions at all about credentials or proofs? Stephen, Severin, I think you're talking.
Hi. What would be an example of the wallet in a mobile device?
Yeah,
Google Authenticator or something like that?
No, it has to be an Aries compatible wallet. So there's a bunch out there that are specifically built for Hyperledger Aries. So Google Authenticator, Apple Wallet, they're kind of built around different sets of protocols. An Aries wallet, an Aries mobile wallet, has to be able to understand how to talk to another Aries agent. So there's some examples are Lissi and eSatis are two wallets that are built out of companies in Germany. There's one called Trinsic, which is built out of a company out of New York. Those three are all built on a .NET framework. And then there's a couple of others. There's one that's published by a company out of Toronto called Northern Block. And there's the latest is there's an open source wallet that's being developed by the community, which is called Aries Bifold. And the BC government is building a BC Gov wallet on top of that, which I don't know if it's got a specific name other than the BC wallet right now. But it's built on top of the Aries Bifold open source wallet, which is built on a JavaScript framework. Good question.
Well, okay, so similar question for desktops. What do we expect users to do? Or is that going to show up in one of your other slides?
You're talking specifically for the pilot? The BC Reg pilot, or?
Well, yes. So users are going to have some sort of wallet for their BC.
Yeah, so typically, and I think for your proof of concept, the end users are going to have a mobile wallet. So I guess there's an outstanding question as to if there's any specific mobile wallets you're either going to recommend or support for the end users. So when you're issuing a credential to a user, they're going to have some kind of a mobile wallet to be able to receive that credential and then to be able to present it.
Is it usually a QR code that you scan, or?
Yeah, so that's so if we want to maybe let me jump ahead to just a second. So I don't know if you guys seen all of your wireframes and flow. You guys seen these slides? Or?
Not everyone has seen that because they're not all part of the ISED project.
Okay, so just to kind of highlight, I'm not sure I can zoom in here. I'm not a, there we go. Everything's different. So, so there's a flow that's being defined for the ISED proof of concept, which covers a lot of the use cases, right? So someone authenticates in BC registries somehow, and they want to be able to connect their wallet to be able to receive a credential. So let's see, so to get a credential, they're explained they need to install a digital wallet. It gives them options and explains them how to install the wallet. And then once they have a wallet installed, then they need to connect the agents. So the way that the agents work is they have to establish a connection with each other. Essentially, they exchange a set of private keys that are only known to those two wallets so that they can have a secure connection with each other. One way of initiating that connection is through a QR code. So you can pop open a QR code and then they can scan it with their mobile wallet. It will interpret the information in the QR code as to how to connect to the other agent. And then the connection will be made between those two agents. So that's the typical use of a QR code, is just going through that initial introduction stage of connecting the two wallets together. So in this case, the end user has a mobile wallet which runs on their phone or tablet, I guess. And they're connecting with the BC Registries agent, which is an Aries Cloudagent Python agent, which runs on OpenShift somewhere. So that's kind of the QR code, where the QR code fits in. The QR code is really just an encoded message that explains to the agent how to connect to the other agent. So there's other ways of communicating that information other than QR code. QR code is the most convenient when you're connecting to a mobile phone. And then once those two agents have a connection, then the BC Registries agent can initiate sending credentials or requesting proofs or any other operations that need to happen between the mobile agent and the BC Registries agent. But that's kind of getting into kind of the next slide, which is, so we know what a non-creds credentials are. A non-creds, the specific implementation that we're using is Hyperledger Indy, which defines basically what a non-creds credential is and how the different operations work, how you issue a credential and how you request or present a proof. But what it doesn't cover is how the applications are actually supposed to talk to each other in order to be able to exchange information. So that's where Hyperledger Aries comes in. So the credential type describes what the credential is and how it works, but what Aries defines is the protocols for the applications to actually talk to each other. So these are the RFCs that I showed you that site earlier. So if you look through the RFCs on the site, then it explains all the different protocols for how agents connect and how they issue credentials and how they request proofs from each other. So Aries compatible applications are called agents or Aries agents. The Aries Cloudagent Python or Aca-py is one agent that was originally developed by BC Gov, but now it's fairly widely maintained. There's quite a lot of contributors to that one now. It runs as a standalone process and you interact through a service-based interface. And then there's other Aries implementations like Aries Framework JavaScript, which is what the kind of the modern or the latest mobile agents are based on, the Aries Framework JavaScript. And so with Aries Framework JavaScript, you bundle the library into your application. So you build an application that is Aries compatible. Whereas with Aca-py, the agent actually runs as a separate process, and then in your code, you just interact with it through a set of web services. And the agents are interoperable based on the fact that they all support the same protocols, and the protocols they can interoperate because they all follow the standards. It's kind of an oversimplified way of doing it. And then there's Aries interoperability profiles, which define subsets. So AIP 1.0 defines is kind of the original set of Aries protocols that were originally developed, and AIP 2.0 includes a more flexible set of protocols. Is built. AIP 2 protocols are built using a lot of the learnings that came out of AIP 1. So Aca-py supports both. So if you're using Aca-py, you can use AIP 1 or AIP 2 protocols. And then the specific protocols you use really depend on what other agents you want to be able to interact with. So there's a question, when would agents need to interoperate? And for agents to be useful, they need to be able to interoperate. If you just have an agent standing alone that can't interoperate with anything, then the agent isn't really all that useful at all. So if we go back to, I'll go back to just this trust over IP picture here, which is kind of a useful picture to have. So in this model, the issuer has an agent, the holder has an agent, and the verifier has an agent. Each one of these three roles has an agent that they are in control over. And for the issuer to be able to issue credentials to a holder, then that's interoperating. The agents have to be able to connect, and they have to be able to understand the protocols in terms of what is the credential that's being offered, and how do I request it, and how do I hold it. And likewise, between the holder and a verifier, these are two agents, and they need to be able to interoperate in order to be able to exchange information, in order for the verifier to be able to ask the holder when to present information, and for the holder to be able to present it.
Okay, thanks. Got it.
Yeah, and so the reason for the standards is that as an issuer, you don't necessarily want to care what kind of agent the holder is using or what kind of agent the verifier is using. So you can use the Aries Cloudagent Python, the holder could use the eStatus or the BCU wallet, and then the verifier can use Aries Framework Go or and anyway, there's a few different language versions of agents that they can use. But the interoperability just means that you can exchange verifiable credentials, and you don't really care kind of what technology the other guy is using, other than the fact that it's an Aries compatible agent. So the AIP 1 and AIP 2, it's really the most significant based on which mobile wallet you want to support for your organization credentials. Most of the all the wallets that are out there support AIP 1, even the ones that have been around for years. There's not as many wallets that support AIP 2. The direction of the community is to go with AIP 2 just because the protocols are more flexible and they've got more features, but some of the wallets that you might want to use don't support AIP 2, or they don't support AIP 2 yet. So whoever is responsible for answering that question, which mobile wallets do we want to support, that's going to determine which of the protocols you're going to use. Just as an example, the BC Law Society, which they've been issuing credentials to lawyers for a couple of years now, they're specifically recommending that their users use the Trinsic wallet, I believe, is the wallet that they're using.
That's the one.
Yeah.
I used to work on that project.
Yeah, and they recommended that one because during their testing, that's the one that they found worked the best. And so just to simplify support, they told all their users to use the Trinsic wallet. That's the one they're using. For another application that I worked on, we used eStatus because we found that that one had the best features that we liked. All the wallets are a little bit different. If you guys want to support, for example, the BC wallet I know is building in a lot of the AIP 2.0 stuff. I don't know specifically of any other wallets that are building in the AIP 2 protocols yet. So if you worked on the Law Society project, then you must know all this stuff then, right? This is all kind of background to you.
A little bit. Wayne, or sorry, not Wayne. Wade spoon fed me a bit. So
Okay. All right. Well, I mean, as if you've got some experience, then if there's stuff that you've found that is relevant that I'm missing, then just feel free to jump in and point it out, or just pop something on the chat. Thanks. Okay, so that's Aries. Hyperledger Aries is a bunch of standards, and there's a bunch of Aries agents. So what is Aca-py? Aca-py is an Aries agent written in Python. It runs as a standalone service. This we found, kind of before Aries, before Hyperledger Aries came into being, we were all just kind of writing our own protocols to talk to each other, for our applications to talk to our other applications, and there was no interoperability. And basically we were bundling all of the libraries into all of our applications, which introduced a lot of complexity. So we found building Aca-py as a standalone service means that it gives us a bit more control of the dependencies. There's a lot of dependencies for working with verifiable credentials, including a lot of crypto libraries. And so by having Aca-py as a standalone service or a standalone Docker instance, it kind of encapsulates all of those dependencies. And then building your application, you don't have to worry about any of that. You're just talking to a web-based, a web service-based interface is all you have to worry about. So this we found running it as a standalone service, it simplifies the application development quite a lot. So you can run it as a service, or you can run it as a Docker image. The code is published as a Python library, but we also publish Docker images. So you can just do Docker run and then just name the image that you want. And it's intended for enterprise applications. So it's not really intended for an end user to download Aca-py and for them to be able to run Aca-py to manage their own wallet. It's more intended for businesses who need to enable their business applications to be able to use or consume verifiable credentials. The comment says nice abstraction. It was based on a lot of experience. So yeah. It's AIP 1 and AIP 2 compliant, so you should be able to use Aca-py with any mobile app. You can't necessarily use AIP 2 protocols with any mobile app, but AIP 1 should be fairly broadly compatible, and it typically runs behind a controller. So when you deploy Aca-py, you deploy it as part of your infrastructure, and then you write a piece of code that we call a controller, which provides business logic, which interacts with Aca-py. And in a picture that looks something like this. So you've got, this is a typical model. It's not the only way to do it, but typically there's a user interface built using something like Vue.js or some JavaScript kind of framework. But if you really wanted to, you could just do like a kind of a vanilla web interface as well. The controller provides a lot of the business logic. It has to store its own data. Typically, if you're extending an existing business application, then you've got a business database already, which has information about, for example, businesses that are operating in British Columbia. So you've got a database already that has all that information. And then you just need to enable some verifiable credential features. So you do that just by standing up an instance of Aca-py and then interacting through the web interface. There's information that obviously the controller needs to store about any stuff that it does. So for example, if you issue a credential, then typically you want to keep a record of the fact that you've issued a credential. So that's, kind of in addition to the fact that you've got information about the business, now you've also want to store information about the fact that you've issued that business a credential relating to the information that you've got about that business. And that's important that your business controller does that, because Aca-py doesn't remember, like it'll issue the credential and then forget about it. So you'll want to know that you've issued the credential, and if the business information changes, then you'll probably want to reissue the credential. So you need to know the fact that you've issued the credential, you need to know what information you've issued, and then you need to be able to decide if you want to reissue that credential or not. You can also keep information about, if the, so I've got another line here that, Aca-py talks to other agents. So there's an interface where the controller talks to Aca-py. There's a different endpoint that Aca-py uses for talking to other agents. So this is secure messaging. So Aca-py will keep track of what are the other agents that it knows about. So when we're talking about, using a QR code and establishing a connection with the other agent, and then, these two agents now have exchanged private keys so they can communicate securely with each other. So Aca-py knows information about that connection, but it doesn't necessarily know, like from a business perspective, who that connection is. So that's something else that you'll need to keep track of in your controller. You've got a connection through Aca-py, but what is the business or the individual who that connection is related to? So you're keeping track in the business database of any business operations you do, as well as any business relationships to things that Aca-py keeps track of. Does that make sense?
Yeah, that does. That was a good explanation.
Okay, so you'll see I've got, there's kind of a bidirectional arrow here. So the controller can call services on the Aca-py agent, but the Aca-py agent can also call the controller to notify the controller that things have happened. So Aca-py exposes a set of web services. If the controller is interested in getting these notifications, then the controller has to expose a service that Aca-py can connect to. It's not required. The controller can just, if they want, just do kind of continuous polling on Aca-py. But it's more productive to receive notifications, and then the controller can just react to any notifications that come back. So for example, any of the protocols, and if you look in the Aries RFCs, most of the protocols are a series of messages that go back and forth. It's not just, issuing a credential isn't just sending a credential from one agent to another. There's kind of a negotiation protocol before the credential gets sent. So in each step of the protocol, when Aca-py gets a message back from the other agent, it can send a notification to the controller, and then the controller will know what to do, or what the next, be kind of notified that it has to take the next step in that, in executing that protocol. And then the two things that Aca-py uses on the back end, one of them is the wallet database, or sometimes it's called a wallet, sometimes it's just called agent storage. But there's a database which is separate from the database that the business uses. The Aca-py wallet is encrypted, so you can't actually, as a developer, log into your database and see the contents of your wallet. Unfortunately, there's not really an option to run it in unencrypted mode. So there's kind of historical reasons for that I don't want to get into. But just so that you know that if you actually need to debug something in Aca-py, it's a bit of a challenge because you can't actually see what you've got in your wallet. And then the other thing that it uses is the Indie Ledger, which is basically just a blockchain or a set of public transactions that people can read. Any questions on any of that? So from a development point of view, you can run everything locally. And so this is typically what we do because there's relationships between what's in the ledger and what's in your wallet. So for example, when an agent records his public key information on the ledger, then the private key information goes into the wallet. If you've got like a public DID or a decentralized identifier, then the public key gets published on the ledger and the private key gets published in the wallet. Likewise, with a credential definition, there's public information that's stored on the ledger and private information that's stored on the wallet. If you're doing development and you've got people who are sharing a ledger or sharing, an Aca-py instance, you have to be very careful because you can step on each other or get your environment out of sync very easily. So what we found is it's just easier from a development point of view, you just run stuff locally. You can start up an indie network. You can start up Aca-py. These are very easy to start up. You can just use Docker or Docker Compose, I should say. And then just run everything locally. I don't know if any of you guys have actually tried running any Aca-py applications at all. But if you have, then hopefully you found that it's very easy to do. So for development, you can run everything locally. You can also, rather than running things like an indie network locally, you can use a shared network. There's a couple of development and test networks that the BC government runs, which you can use. Some people prefer to do it that way. I prefer not to because, like I say, there is a danger of stepping on each other's toes when you're using these kind of shared resources. So anyway, so you run the indie network using the Von network. You run Aca-py by just firing it up from whatever. You can use the Docker image is the easiest way to do it. And you can set up a Docker Compose that starts everything up, including your own controller and database, etc. And you can see if you look in the BCGov projects, for example, if we go to github.com BCGov and we look for orgbook. Orgbook is one of the original actually, what's it called now? It's called Aries VCR. It's one of the original Aries applications that was ever built. There's a Docker Compose, and you can see within the Docker Compose how all the different components are fired up. So there's lots of examples for how to set up a development environment. But again, that's something that I can help out with if you want to have kind of a follow-up discussion about specifically what's the best way to set things up so that developers are running stuff locally, then I can help out with that. And then typically for deployment, what we've done for most of the organizations like you guys that are starting up with Aries is that we run and manage the Aca-py instance. And I mean, it's not required. You guys can run your own instances if you want. But we found that it just makes things a little bit easier from a development point of view. That is one less hurdle for you guys to have to hurdle. We can run an Aca-py instance. We can give you the different endpoints that you need and the API key information, and then you can just interact with it. And then you just have to worry about what other pieces you want to deploy, where you want to deploy them, and just making sure that whatever endpoints need to be public are public. So I imagine, unless I hear anything differently, that we're going to be standing up and managing an Aca-py instance for you guys. And we've got a fairly standardized way of doing it. We've got a repository that's totally dedicated to just all the different Aca-py instances that we run. So it's fairly straightforward for us. You'd be set up similar to how we've set up for the Law Society, where we just run an agent. And then we've got different endpoints that are available to interact with the agent. And typically when we do this, we set up a dev, test, and prod. to kind of mirror, assuming that you guys are going to have something similar when you're deploying your own components, that you'll have a dev test and prod deployments, and we'll have Aca-py instances that mirror that structure. If you're doing anything different than dev test prod, or if you've got something more complicated, then that's something we need to talk about, how to support that. I'm not sure the model that we've got for doing kind of the standard Aca-py support supports that, or if it's just strictly dev test and prod. Any questions about that? Any questions about any of the background so far? Verifiable credentials, ND, Aries. I was going to start getting into now some actual demos that I will run through, and hopefully you'll be able to either run along in parallel with me, or depending on how you want to do it, or you can just watch and try to run these demos later on yourself. It's up to you what you want to do. If you are deciding you want to run these yourself and you want me to just kind of wait, or if you're finding yourself falling behind because I'm going too quickly, just let me know and I'll pause and wait for you. But a lot of the demos are described in the Aries Cloudagent Python repository. So if we go to this repository, there's actually quite a lot of good documentation in here. A lot of the times I find that, people who have questions about Aries or Aca-py in general, it's just they haven't looked through the documentation, or they haven't been able to find it. If you do have any questions, feel free to look through the documentation, or feel free to reach out and ask me questions as well. Possibly if there's documentation there, I'll just point you to it, but I'll try to give you something a little bit more useful in terms of information. We've got the main demo in here. We call it Alice Faber, and it does a very simple use case, issuing a credential and then asking for a proof. And really it's to give developers something that they can run, that they can interact with, and as well a piece of code that they can go and they can look at to see, okay, well, this is what the demo is doing. What is the underlying code actually doing to implement that? And so you can look through the Alice Faber code, and it's all Python, but you can see exactly what it's doing in terms of interacting with the Aca-py agent. So there's different ways to run it. You can run it in a browser if you play with Docker, or you can just run it in Docker. You can run the code locally. The easiest way to do it is just to run everything using Docker, which I will show you how to do. So in the scenario, Faber is an issuer and verifier. We kind of bundle those two roles in with Faber, and then Alice is a holder. And Alice and Faber are both controllers. So if we go back to this kind of controller model, then really the Alice Faber code is the controller code. And the way the demo works is that each of the controllers just fires up an Aca-py instance as a sub-process. That's the easiest way to do it, because there's a couple of options when you run Alice Faber. There's a couple of options that you can specify for picking different Aca-py configurations. And so then the controller can just start up Aca-py using whatever parameters it needs. So they're both controllers. So the controller, I mean, this is more analogous to the code that you guys are going to need to write. So if you look at the Alice Faber and you see what they're doing, then that's kind of the code that you're going to need to incorporate into your own controller. You're probably not going to start up an instance of Aca-py. Like I said, you'll probably use Docker Compose or something to start it up, to run it as a separate instance. But from a demo point of view, that was just the easiest way to do it. And then you can interact with the controllers. You can review the Python code. You can see how it interacts with Aca-py agents. If we go back to the GitHub, then the code is actually under runners. So if you look in runners, then there's a script for each of the agents. Alice, Faber are the two that we commonly run. There's a performance demo, and then there's an Aca-py demo as well that you can read. If you go through the documentation or the demo, you can see the documentation about these, but really the Alice, Faber are the key ones. Agent container is a set of common code that's used by both of these. And then under support, there's more, kind of common libraries that are used by the two different agents. So if we just jump right into it, then, so to run Aca-py locally, there's basically 3 shells that you need. You need to start with 3 bash shells. In one shell, you're going to run the network or the Indie ledger. And then in the other 2 shells, in one of them, you're going to run the Faber and agent, controller and agent, and the other one, you're going to run the Alice controller and agent. So I'll just go through and do that right now. So I've got actually 4 shells here set up. The 4th one is for revocation that we'll talk about later on. So you start by cloning the repository. So let's make sure I'm in the right place. So Von Network is just an easy way to start up an Indie ledger. So I cd into Von Network, I do manage build. Everything is done through Docker Compose. We've got a script that kind of wraps Docker Compose that a lot of the BC Gov applications that you'll see will have a managed script. And so it's just a consistent way that, I don't know, we started out doing it this way and it seemed to work. So we continue to do it that way. It's not really a Docker standard, but it's kind of a convention that we used in BC Gov. So then when you run the network, you do manage run and you say -logs, which means you want to, oops, what did I do? Manage start, sorry. So just a bit of a background on Indie Ledger. It's like any blockchain. You can have any number of nodes that support the blockchain. And then in order to introduce information onto the ledger, you have to have consensus among the nodes. There's a minimum of 4 nodes that are required for an Indie Ledger. So that's why we run 4. I think with production ledgers, they usually run with about 30 odd nodes, but for development, we can get away with 4. So we just run 4. And then we also run Von Web Server, which is just a ledger browser. So if we look at the ledger browser is available at localhost 9000 and is useful because you can see kind of what is happening here. It's not starting up for some reason. It's just taking a while. Normally it's faster than this. It seems to run slower when I'm trying to do a presentation.
So in prod, like how many nodes are you typically running for the ledger?
About usually about 30 nodes. So the ledger itself is it's a permissioned ledger. So anyway, this is what you want to look for. When it's finished up and running, you'll see a message that says finished resync. And that's how you know it's ready. You also know it's ready if you fire up the ledger browser and you can see that it's actually displaying information. So in our case, we're displaying information about the nodes, each of the 4 nodes that's running, and then we can look at the ledger state. You can look at the different transactions that are on the ledger. There's 5 transactions that are on there right now. Each node has a NIM. A NIM is another name for a DID. decentralized identifier. The reason why the name is different is because the Hyperledger Indy was released before DIDs were ever conceived. So I guess the Evernym, the company that originally wrote Hyperledger Indy, they invented NIMs before the world invented DIDs, and then they realized that NIMs and DIDs were just the same thing. So anyway, for the base network is that there's each of the nodes is called a steward, has an identity, and then there's a kind of a master identity called a trustee. And just in general, the DIDs are have roles. So there's trustee and steward, which are kind of reserved for running the network. And then if you're an actual agent, then you will have a role either of endorser or none. And depending on which role you have, it determines whether you can actually write transactions to the ledger or not. So Hyperledger Indy network is read. Everyone has read permission, so anyone can read it, but you have to have specific roles in order to be able to write to it. And because it's write permission, then the nodes that are running the network, they're really just validating that the transactions are signed properly and that they're being recorded to the ledger in the right order. So you don't get a lot of benefit by having thousands and thousands of nodes supporting the network. The more nodes you have, it just complicates the whole ledger negotiation process, where it's negotiating for new transactions to add to the ledger. Whereas you want as many nodes as possible to prevent, kind of the N+1 attack, but you want as few as possible to make the operation of the network itself the most efficient. And I believe it's something around 30 odd nodes is the kind of the number that they've kind of picked for running a production network. Any questions about the network? So next we will run our Aca-py. So I'll go back here to do my git clone command. So we'll clone the Aca-py, and from here I'm basically just following a lot of the instructions that are in here. There's different options that you can run. So there's a lot. The demo is fairly flexible in terms of how you run it. So just for the demo, I'm picking kind of the simplest use case in terms of how to run the demo. And so we'll cd into the demo directory, and then the simplest command for running the demo is run demo Faber. And it will create the Faber image and start up the Faber demo. And then at the same time, we can start up Alice. Alice and Faber both run against the same Docker image, basically. So we start them both up at the same time. So you can see when it's starting up, you can see that this is the command that Faber uses to start up its agent. So these are all different parameters that you pass to Aca-py when you're running an agent. There's quite a lot of parameters available. It's a fairly flexible application. That's timing issue. Let me just kill all this stuff. Sorry, this is one of the problems I have when I'm trying to do this and doing presentation at the same time, is that I've run out of juice on my machine here. But basically, the error that's happening is that the Faber controller is starting up an agent, and because I was doing a bunch of other stuff at the same time, I got a timeout. So here, so when the Faber agent starts up, it just gives a bit of information about its own configuration. It's running version 0.74 of Aca-py, which is the most recent release, which I believe is about a month or 6 weeks old. And then it's got two endpoints that it publishes. So the HTTP port 8020 is the port that is used for communicating with other agents. So in this diagram, that's this line here is port listening on port 8020. And then the other one, the admin API is on port 8021. So that's this port right here, which is 8021. So the controller talks on port 8021 and the other agents talk on port 8020. And 8020 obviously has to be available for other agents. So it has to be public. The 8021, depending on how your environment is configured, it just needs to be available for your controller to be able to connect to. And when Faber starts up, the first thing it does is it creates a schema and credential definition. And this is the structure of the schema. You can see that the schema is fairly straightforward. It's just a list of attributes. There isn't really any information about, what these attributes means. If someone wants to look at that credential, they need to understand what these things mean. The only difference is there's one which is birth date _ date end. Date end is a convention that the date is in a particular format, year, month, day, just for identifying that it's, it's kind of an integer version of a date that you can do math and comparisons with. I believe that that's defined in one of the Aries RFCs somewhere. But this is actually just talking about the anon-creds versus W3C. This is where W3C has a much richer expression in terms of what the information is that's in a credential, whereas with anon-creds, it's just a list of strings essentially. So this is the invitation that we create. So this content needs to go to the other agent in order to be able to connect. So I'm just going to copy that. And you can see in here that it's got this 8020 endpoint. So this is what is advertising as its own endpoint. So it's host.docker.internal just because it's running all on an internal Docker network. But the port 8020 is what the other agent will receive so that it knows what to talk to. And if you're running this thing behind OpenShift, so you've got some kind of a path, you define some kind of a public path for this endpoint, then you can configure Aca-py so that it knows what URL to advertise to other agents. And just in terms of we had a question about QR code earlier. This QR code is what this invitation looks like QR encoded. So I could either scan this using a mobile device, or I can copy and paste this and put it into another agent. So because we're testing from Aca-py to Aca-py, we will run Alice. And you can see Aca-py or Alice is on port 8030 and the admin API is on 8031. Alice wants an invitation, so we give her one, and then the two connect. So now the two agents have a connection between each other and can do things like issue credentials and send proof requests. So for this demo, this is really like the intent of this demo is really to provide developers with something that executes the protocol. So it issues a credential or it sends a proof request. And then visually, it doesn't really do much. I can issue a credential and then, Alice, you can see there's kind of a negotiation that goes on here. The offer is sent, request is received, credential is issued, and then finally is acknowledged. And if I go on the Alice side, then Alice has received an offer, sends a request, received a credential, and then this is the credential that Alice eventually receives. Likewise, I can do a proof request. This is where we've got Faber as a verifier. So sending a request for a presentation, receiving a presentation, and then validating it. So from a development point of view, like going through the menu like that doesn't really tell you anything, but if you go into the code, then you can see, if you go into like Faber, for example, then you can see within Faber where it is actually running the running these operations. So this setting up the menu for options that are available, and then it just goes into a loop, tell me what to do, and then based on the option that the user selects, it will, option 1 is issuing a credential, option 2 is requesting a proof, and then you can see within the code here, we've got options for AIP1 and AIP2, depending on which version of their protocol we want. So you can see that for AIP1, it's just a matter of calling the issue credential send offer endpoint, which initiates the protocol. With AIP 2.0, it calls the issue credential 2.0 send offer, and then you can follow through the code to see the different message initiation and response that comes back. So I'm not going to go through that whole thing right now. I just wanted to kind of point out that it's one way of kind of digging into the code and seeing what's going on, is going through the Python code. That's originally why we put the demo together, was more of a developer oriented thing that developers could go into and actually see some running code, interact with the code, and then look in the code and see what it's actually doing. Any questions about any of that? So what you guys are actually going to be interacting with, and actually before I go there, it might be useful just to take a look at the ledger. So now we've started up Faber, and we now have 11 records on the ledger now, because we started with 5, but then we started up Faber. So everything from 6 onwards are things that Faber has done. So the first thing we did was that we registered a DID for Faber. Agents optionally can put an alias to make it easier for people to look on the ledger and see who their DID is registered for, but it's not required. And the role is endorser. So we've registered Faber as an endorser so that Faber can write their own transactions to the ledger. The attrib is metadata that's attached to the credential or attached to the DID. And in this case, the metadata is just the endpoint that we're publishing for that agent. So again, that's the public endpoint that other agents will use to connect. In the demo that we did between Alice and Faber, we actually included all that information in an invitation that we sent. But the other approach is that Alice could just look up the information on the ledger and then initiate a connection request with Faber directly, just by looking up the information that Faber is registered there. There's another NIM, I think just because I ran through Faber twice. The first time I ran it, it crashed. And so now we've got Faber with a second NIM and a second attrib there. And then the next piece of information that Faber records is the schema. So this is the list of attributes that are going to go into the credential that we're issuing. I mentioned that the schema can be created by anybody. Likewise, once Faber records a degree schema, then anyone who wants to can issue credentials based on that degree schema. There's nothing preventing anyone from using that schema at all. And then the other thing that Faber records is the credential definition. The credential definition is what it actually links the credentials. You can see there's an additional attribute on here called the master secret. That's part of the private key information that's stored in the wallet. So there's an attribute called the master secret. The actual master secret data is stored in Faber's wallet, and that's linked to this particular transaction on the ledger. So only Faber can issue credentials against this credential definition because it was recorded using Faber's NIM, but also Faber has an additional master secret that's created. And if you look at the raw data, then you can see that there's a bunch of all this crypto gobbledygook that's attached to the credential definition that you're never going to use it yourself. But when Alice is actually presenting a credential to a verifier, then this is what the verifier looks up to be able to verify all the crypto math, to verify that it's actually a valid credential that was issued by Faber. Any questions? So the actual API that you interact with for Faber, for example, so there's a Swagger page. Aca-py publishes a Swagger page so that you can play around with your agent. You can just interact directly with any of these APIs. These are the same APIs that are called from the Alice Faber code that we just went through. And there's a document in here. Let's see where I am in the presentation here. So the APIs are available for Faber's 8021 API doc. You can browse the ledger at 9000. I'll show you that. And there's a demo that does a walkthrough of the APIs. So specifically the APIs. So there's a open API demo. So what this document describes, I think that's the one I linked, Aries Open API demo. So it describes how you actually go through each of the operations interacting with the API endpoints directly. So you start Alice, you start Faber, and then using the Swagger interface. So you open up the Swagger for each of your two agents. So we'll go localhost 8031 is Alice. So we've got the API for Faber, we've got the API for Alice. So all the stuff that we just did through the controller, we can do directly by interacting with the API directly. So establishing a connection, for example, if we're using the Faber agent to create an invitation, then we can go into the connections, create invitation, endpoint. Actually, if we look at connections first, so if we want to see what connections are already available, then we can see that if we execute, we can see that we've already got a connection with Alice. So this is the one that we just created when we went through the invitation and initiation step that we did through the Alice Faber controller. But we can do the same thing just by going through each of the API points individually. So we call create invitation. All this stuff is optional. We can just take it out. I think that should be explained in here. So it explains, the documentation explains each of the endpoints, and it's got screenshots of how you actually call the endpoint and then what the response should look like when you get it. So if we go into create invitation and we call it test invite 1, and then we execute, then we can see that it gives us a couple of things. First of all, it gives us a connection ID. Now, when I mentioned you need to store something in your business application, that's something that you need to store in this case is your connection ID. So when you reference this connection from your controller, you reference it using the connection ID. So when you create an invitation or when you establish a connection, you have to know who you're connecting with, so that from a business application you can link the connection ID with the correct identity. The invitation is the JSON invitation structure that you actually need to send to somebody. So if you're sending this to another agent, then this invitation is the content that you actually need to send. So you can see it's got the service endpoint, it's got our label, and it's got some information about what kind of connection we're actually sending. And then the recipient keys is, I mentioned, we're exchanging private keys with each other's, or we're exchanging keys with each other so that we can securely communicate. So the recipient keys identifies how the other agent needs to communicate with us. And then this information is actually base64 encoded into this invitation URL. So this base64 here is actually, if you base64 decode that, you actually get this JSON structure. And when you're QR encoding something, you're actually QR encoding the URL as opposed to the actual JSON structure. So Aca-py gives you both. It gives you the JSON structure and it gives you the URL. Depending on how you want to communicate with the other agent, you either use the JSON structure or you can use the invitation URL. Any questions? This this document here, the Aries Open API demo, basically describes the three things that you're going to need to do at a high level. So establishing a connection between the agent, and then doing messaging. So preparing to issue a credential. So how do you actually go about issuing a credential? How do you issue the credential? And then how do you request a proof? So those are the main things that you guys are going to need to do. And the API point, the APIs that you need to use are all described in this document. So this is probably a key document for you guys to go through. If you guys want, if you go through this document and you're still finding it a bit confusing and you want to do like a kind of a follow-up session and go through this stuff specifically in more detail, then we can do that. I don't want to do it right now because it really is something that, like, to get the value out of it, you need to go through it yourself. I don't know if anyone is actually trying to go through any of this right now with me as we speak, or is everyone just watching?
I got it running.
Cool.
I'm just watching.
Awesome. Cool. Anyway, so we'll leave this for now, but you take this as a to-do that take a look at this. It goes through the different APIs, and then if you have questions or you want to do a follow-up session where we go through this in more detail, then let me know and we can do that. Next thing I wanted to talk about was interacting with a mobile agent. So there's a couple of ways to do it. Anyway, it's described in this other document, Alice Gets a Phone. So if we take a look at the document, then it describes a couple of different ways that you can run everything in order to be able to talk to a phone. Some of the main things that you need to know, that you need to be able to do, is you need to, first of all, you need to use a ledger that the phone knows how to connect to. So this is a scenario where you can't just run Von network locally because your mobile device doesn't know how to connect to your local machine, and likely, you know, anything you're running on your local machine isn't going to be published publicly anyway. So when you run the demo, one of the things you can do is you can specify a ledger URL. And in this case, if we use test.bsovereign.vonx.io, this is it's actually just an instance of Von network, but it's running on DigitalOcean and it's publicly available to the world, and is used quite frequently as for people running demos. And you can see that it's got, you know, over 400,000 transactions registered on it. So it's a good example of a ledger that is running out there in the world publicly. It's only running 4 nodes. So even with 4 nodes, it's still able to handle quite handily the load of all of the various demos that people have been running against it. The only issue with just running 4 nodes, as I said, is that it's less secure because it's easier for someone to attack if they want to do the N+1 attack on it. The other thing that you need to do is going back to this diagram here, this connection here, the other agent, when you're talking to a mobile agent, the other agent is on a mobile phone. So it needs to be able to talk to your agent. So your port that you're publishing, your port 8020 needs to be published on a port that the other agent knows how to get to. And there's a couple of ways of doing that. I don't know if any of you guys are familiar with Play with Docker. I will just do a very quick demo of Play with Docker. Is useful because Play with Docker is useful because you basically run everything in a browser. So you have to log in with your Docker credentials. Hopefully this remembers them. And then it starts a session in your browser. You can add instances of shells. So you can add however many shells you want to run. And then you can just run all the commands in the shell here. Any ports that you open here, Play with Docker will automatically expose them for you, and it will give you a very long Play with Docker URL that is a public URL. So this is one way to do it. Like I said, it's the easiest in terms of you don't have to have anything installed in your local machine. Everything just runs off in the cloud somewhere. And the scripts that we've got, so when you do run demo Faber, it knows how to check to see whether you're running on Play with Docker or not, so that it can publish the correct URLs when your Aca-py agent starts up. So you can play around with this if you want. I'm not going to demo it this way because I find with Play with Docker, it's got a limited amount of resources. So probably about 50% of the time that I try it, it just doesn't work. You run out of resources, or you're trying to do a build that can't create the Docker container or whatever. So it's useful if you just want to play with something on your own. We've tried to do workshops with using Play with Docker, and we find after about 2 or 3 people, the whole environment just crashes. So the other way you can do it is you can use ngrok to publish your agent endpoint. So in our case, we know we're running our agent on port 8020, so we just run ngrok on port 8020. I'll do that in my other shell here. Are you guys all familiar with ngrok?
I am.
I can kill, actually, no.
I'm not.
So what ngrok does is you give it a port, and basically it exposes it publicly for you on this URL. So I give it 8020, and then it says, okay, well, you can use HTTP with this URL or HTTPS, and it will forward any traffic to localhost. So you have to run ngrok locally. So ngrok is running on your local machine as kind of a proxy, and it allows you to publish stuff that you're running locally. It allows you to publish it. So in this way, if I advertise my agent on this URL, if I advertise this is my endpoint, then ngrok is going to forward all the traffic to this local URL. And again, if I shut down my Alice Faber, and actually before I do that, I'm going to change the color here, if I remember how to do it. Inspector, ocean. So I will do run demo. Actually, why don't I just copy the command from here? So a couple of options that I'm specifying here. I'm telling it what ledger to use. So I'm telling it to use the test-b sovereign ledger. And I'm not, I've shut down my local VON network, so I'm not running a local network. And I've also told it I want to use AIP 1.0 because I know that the mobile app that I'm going to demo it with only supports AIP 1.0. It doesn't support AIP 2.0. So this will make sure that the demo runs only the specific endpoints that I want to run. So I've got, and hopefully this works, because I've also found that about 50% of the time when I try and share my phone, it doesn't work. So I've got on here, I've got a couple of agents. I've got Trinsic and I've got eStatus. I've also got the BC wallet. I'm going to demo with eStatus just because that's the one that I use most often. So when I start it up, it got integrated biometrics, so it checks my face, makes sure that I'm the guy who's using it. And I've got some credentials that I've already downloaded from other issuers. So I can see the credentials that I've got, and I can see the connections. So this will show me what other agents I've connected my phone with. So there's 3 of them. There's Secures, Myco, and this researcher agent. Don't worry about any of that. Just as an aside, when I mentioned that some agents have different features, the feature that we liked with eStatus was that when you've got a connection with an agent, it will show you the different activity that's happened under that connection. So there's proof request, credential, proof request, and those are basically the 3 things that have happened under that connection. Not all wallets will provide that. I can see with my code that I've got 3 credentials that have been issued and so forth. Anyway, this is a feature that's available in eStatus that's not necessarily available in the other agents. So that's something that you may want to look at when you're deciding which agents you want to support. So here I've got the invitation data. We can see that I'm now publishing my service endpoint as the ngrok endpoint. So that's automatically picking up the fact that I'm running ngrok on port 8020. Again, that's the run demo script that we've got is the one that starts that up. And because I'm dumping this out as a QR code, I should be able to scan the QR code from my mobile device and be able to connect to that agent. So it comes up, it tells me Faber wants to connect with you. I click on connect. It negotiates a connection in the background and then tells me I've successfully added that connection. So from Faber's perspective, because it's Aries and we're all following the same interoperability protocols, Faber doesn't care. And like when you guys are building your application and issuing credentials, it doesn't matter whether you're issuing to a mobile app or another Aries app, it looks the same to you. So in terms of testing, you can think about whether you want to jump into issuing to mobile directly, or you can fire up 2 Aca-py agents and issue from one Aca-py agent to another Aca-py agent. From the code that you write, that your controller needs to write, it doesn't really make any difference. You've just got one agent talking to another agent. So likewise, when I do issue credential here, I say number 1, issue credential. Because I've got a connection between my Aca-py agent and the mobile, it now knows how to communicate. So this message is coming over that connection. It says you've got an offer. Here's the credential that's being offered. Do I want to accept it? If I accept it, then it sends me the connection. I accept it, and then it successfully stores the connection on my wallet. So that's what it looks like from a mobile app perspective, receiving a connection. If I want to respond to a proof, then Faber can send me a proof request. From the wallet's point of view, it says view request, you've got a request for a proof. It shows me the data that's being requested. These first 3, it's asking me for the value. It's not super clear from the user interface that this is what it's asking, and this is something that the BCGov folks are working on in the new BC wallet, is to make the user experience a little bit more explicit as to what's happening. But what's happening here is there's 3 attributes that Faber is asking for: the name, date, and degree. And Faber is specifically asking Alice to send the value of those 3 attributes. And then the 4th one here, you can see because it's a condition. birth date int is less than or equal to 2004 08 11, that's really checking my age, right? So the date of birth that in my credential is 1998, so obviously it's less than 2004. So this birth date satisfies this condition, but the birth date is not actually going to be shared with Faber. It'll be shared that yes, this condition is true, but I'm not actually sharing the actual date. So this is what's known as a zero knowledge proof. So then when I click on send, and it sends that information, then Faber receives the information, runs a validation. Proof equals true means that all of the cryptographic stuff is verified. The data that I sent is valid. It's the data that was issued to me. I haven't tampered with it. And the data was issued by the entity that says it issued it. Any questions on that? All good?
Thank you.
That's great.
So that's the basic of Aca-py. I mean, there's more to it. And I guess I've got time to talk about revocation, so we'll talk about revocation at the end. But the main processes are, first of all, setting up the agent. Setting up the agent involves registering a public bid on a ledger, creating a wallet database. This is stuff that we can kind of facilitate with you in terms of your dev, test, and prod environments. When you're running locally, you can look at examples in the BCGov repositories to see how that's done. Basically, what we do in the Docker Compose, because when we're running with a local instance of on network, then we just shut down and reset the environment when we want to retest it. So we can start up the environment. We're usually starting up on a clean environment. So when we register the public bid and create a wallet database, we're usually starting from kind of square one. Credential setup involves creating the schema and credential definition. Again, this is something that we can help you with in terms of registering this information. But in order to first you need to decide what information you actually need to include in your schema and credential. So you've got two credentials, as I understand it, one of them for the verified owner and the other one for a verified relationship. So once you decide what attributes are going to be going into those credentials, then we can help get the schema and credential definition defined and set up on the ledger. These are kind of one-time things. This is the agent setup is one time for your agent. You just need to do it once. Or if you're running a local development environment, you run it every time you reset and start up your development environment. The credential setup you need to do once per credential. So if you're issuing two credentials, then you'll have two schemas and two credential definitions. If you decide to change your credential, so you might decide, that you've created a schema, but you missed an attribute and you want to add a new attribute to it, then the schemas are versioned. So you can't delete a schema or edit it once it's been registered, but you can create a new version of that schema. So you create a new version of the schema and then you create a new credential definition based on that schema. So the credential setup is once per credential, or if you ever change your credential or add information to it, then you have to go through the create schema and create credential definition again. Oops, sorry. Issuing credentials is once per credential. So every time you issue a credential, then you go through the credential issue process. The prerequisite for issuing a credential is you need to connect to the holder agent. Hopefully you just need to do that once, and then once you've connected to each individual, then it's just a one-time thing to connect to the individual. And then if you need to issue or reissue the credential, you can do that against the same connection. If you're ever verifying, I don't know if there's any use case you guys have where you're actually going to be doing the verifying, or if in the ISAD banking use case, I think it's the banks that are actually doing the verifying. But again,
For MHR, we'll be verifying the lawyer credentials.
the which credential, sorry?
The lawyers.
Oh, the
Law
lawyers.
Society.
Okay. Okay. So the lawyers are verifying their identity before you issue a credential to them.
For MHR, it's just verifying that they're a lawyer.
Oh, okay.
Is that going to be like integrated into Keycloak? Just curious.
I believe it is. When the lawyers authenticate right now, I believe it is integrated into Keycloak.
I know another project, so I was curious for this project. Sorry.
Yeah, I mean, there's different use cases.
Yep.
I think for the lawyers accessing the court systems, all the court system needs to know is that it's a lawyer. It doesn't care who it is.
Yeah.
So the authentication is built into Keycloak, and then Keycloak just tells the court services yes or no whether the user is allowed into the system or not. And that's useful because then you can have different authentication methods with Keycloak, and the court systems doesn't even care. You say, okay, well, we'll accept either or whatever.
You set up VC as a provider.
Yeah. So the other use case for proofs though is, for example, you might want to have another step in here. You might want to connect to the holder agent, and then you might want them to prove who they are before you issue them a credential. So for example, let's say that the BC Services Card folks, they're currently working on issuing a verified person credential. I don't know the timing of that, and I don't think that's in scope with your pilot, but if you imagine that that's something that's already out there, then you might do the connection between your agent and the holder agent. And then the second thing you do, ask them for a proof to say, we want to see, your verified person credential to prove who you are. And then once they've proven who they are, then you can record that against that connection. You can say, oh, okay, well, with this connection, we know that it's, Ian, because he sent us a proof based on his BC Services Card verified person credential. Now we can issue him a credential. So that's a scenario where you don't necessarily want to have that integrated with Keycloak. Anyway, so these are the main processes, and just in terms of the setup, when we set up the agent on OpenShift, this is the information that we well, there's a bunch of information, but this is the information that we will need to work with you guys to figure out or to get, to make sure we configure the agent. So the label is the agent name, and it's the label that's published in an invitation. So when we looked at, for example, Faber's invitation, there's a label called Faber Agent. That for you guys will be whatever you guys want to call yourself. So this is the name that's advertised to other agents when they're connecting with you. That's what they'll see in their wallet. So that's something that we'll need to just understand what you want that to be. There's also an image URL. Some mobile applications will just, like if you give an image URL, then that would be included as part of the invitation, and some mobile applications know how to display that. So you get a little icon next to the connection. Not sure if check if eSatis does that or not. Yeah, you can see these icons here don't have anything to do with anything that's being sent. I can't remember if this is something that we initiate from the agent side or not. Anyway, it's something that's optional, and this is an example of an image that's used with one of the, I can't remember who's using this one. It is just a little BC Gov icon. The seed for the public bid. Now the public bid is, there's two parts to it. There's a did and a ver key. The did and the ver key are published on the ledger. And then there's the third part, which is the private key, which is stored in your wallet. The seed is, you can use a seed to generate all three of those things. So you can use a seed if you want to be able to reproduce the same did. You want to be able to start an agent and you want to reproduce the same did every single time. You can do that by generating it from a seed. Obviously, since the seed can be used to derive the private key, you have to treat the seed as if it was a private key. I'm not sure what protocol we use, like in terms of communicating between you guys and us when we're actually setting up your agent to make sure we keep this information secure. But anyway, just keep in mind that the seed is essentially the private key for your did, and you need to treat it like a private key. The webhook URL and API key. So when we're talking about this arrow here from Aca-py to the controller needs to expose a service for Aca-py to be able to send notifications. So that's a piece of information we need to be able to, where was I? That's a piece of information we needed to be able to configure the application. And then we can include an API key or not. If you want an API key, you give it to us, and then every notification includes that API key, and you can validate that the webhook call came from us, because we should be the only ones who know the API key. And then likewise, there's an admin API, which in this case is just localhost, but obviously if we're publishing this on OpenShift, it'll have a big OpenShift URL. And you can run this API in secure and insecure mode. For the demo, we just run it in insecure mode, but if you run it in secure mode, then you also need to provide an API key when you're calling any of the endpoints. So obviously for any agents that we're running in production, we do that. We create an API key and then we give that to you. And then you have to make sure that your agent provides an API key on any API calls that you make for Aca-py. Any questions about that? I assume, Thor, you're the main contact for this kind of stuff?
So I'm told.
All right, well, if there's anyone different, just let me know. What I'll do probably next week, I'll kick off the whole process of getting your agent set up. I'll talk to Wade Barnes and just make sure I understand all the things that need to be done, and I'll get the agents, I'll start the process for getting your agent set up for dev test and prod. In the meantime, I guess you guys can take a look at whatever you want to do in terms of local development. So the last topic I wanted to get into was revocation. Revocation is an additional complexity on top of issuing credentials. I don't know if this is part of your scope or not for a proof of concept. It's pretty straightforward doing credential revocation. First thing is that it involves a revocation registry or tails file. Basically what a tails file is it just a file that contains a large number of big prime numbers. And so, a revocation registry of size 1,000 will have 1,000 large prime numbers in it, and then you can issue 1,000 credentials against that revocation registry. So each credential will be assigned an index within that revocation registry. When you issue a credential, you'll get 2 extra pieces of information back. You'll get the revocation registry ID, and you'll get the actual index within that. And that's additional information that you need to store. So when you issue a credential, you also need to store the revocation information if you decide that you want to revoke that credential in the future. When credentials are revoked, then that's the information that you provide to the endpoint. You say, please revoke this credential with this revocation registry ID of this index. And what happens is that when credentials are revoked, updated accumulators are published on the ledger. An accumulator is just like a sum, or not a sum, but a product of all of the prime numbers. Somehow it's just basically a mathematical operation. So if you want to know which credentials have not been revoked or which credentials are still active, then you check the accumulator, and you can multiply everything in the tails file and it should match up with the accumulator. When the verifiers are checking to see if the verified credential has been revoked or not, all they're given is the accumulator. So they can't necessarily look into the tails file and identify which of the revoked credentials is being revoked or not. All they can check is to see that if a credential that they've been presented has been revoked or not, based on whether the accumulator matches. So it's a secure way of doing revocation. You don't need to know anything specific about the credential. You just need to basically look at the accumulators of the tails file. If you're interested in all the crypto math behind that, then you can Google for a non-cres revocation, and there's white papers that have been written on it. But for me, I just kind of trust the fact that it works. Anyway, the controller just needs to store a couple of extra fields: revocation registry ID and credential index, and then that's what they use to tell Aca-py to revoke the credential. And then holders can be notified. So when you revoke a credential, you can optionally send a notification to the holder so that they know that their credential has been revoked. But it's not mandatory, and not all mobile wallets support it anyway. But it's an option. So how does this affect the processes, revocation processes? So the agent setup requires a tails server. There's a tails server available, like similar to Von Network. You can run a tails server locally. Again, similar to Von Network, we've got tails servers that the BC Gov runs publicly that you can just use. But you need to configure your agent so that it knows which tails server you're going to be using. And then Aca-py manages all the revocation registries, but it just needs to know how to talk to the tails server. As part of the credential setup, when you create a credential definition, it has a flag where you say you want to enable revocation. So if you look in the API, it's fairly straightforward. Creating a credential definition, you just say support revocation true. So true or false, whether you want your credential to be revocable. And then revocation registry size is how big you want your revocation registry to be. We usually use between 1,000 and 10,000 as kind of a trade-off between the size of the revocation registry and the number of credentials. So with a revocation registry size of 1,000, you need to create a new registry every 1,000 credentials you issue. So the smaller the revocation registry size, the more often you need to create a new one. You don't need to worry about it too much. Aca-py does it all in the background, but it's just a process that takes a certain amount of time to do. On the other hand, the bigger the revocation registry size, the bigger the physical size of the registry. And when the agents are, downloading revocation registries to do the validation, then, they need to download bigger files. So the smaller the size, the easier it is for the different agents to be able to validate. But then the more frequently you need to create new revocation registries. When you issue a credential, you don't need to do anything other than store the information. Once the credential definition enables revocation, then credentials are issued as revocable automatically. So there's nothing else you need to specify, but you get back extra information that you need to store. And then when you revoke the credential, you provide that revocation information to Aca-py, and then Aca-py can notify the holder if you've got that enabled. And then when you do a credential presentation as a verifier, you can decide whether you care about revocation or not. So irregardless if it's a revocable credential, when you're a verifier, you have to say whether you're interested in revocation. So there's a flag that you put in the presentation request that says, yeah, I care. I want to make sure that the credential they're presenting is non-revoked. So it's up to the verifier to decide if they want to take advantage of the revocation or not. Any questions about that?
Nope, pretty straightforward. Thank you.
So to demo this, we just run the Vaughn network as we did before. Let me just kill my agent here. I'll kill my ngrok. So I start up my Vaughn network. In the meantime, while I'm starting my Vaughn network, I can run git clone on Indy tail server. So let's make sure this guy's started up. Anyway, the tail server is similar. You do manage build to build the Docker images, and then you do manage start to start it. Hopefully I can do two things at once here.
Ian, I'm going to drop off. This has been excellent, by the way. I appreciate it, and
Thanks.
appreciate you letting our larger team come in, because everybody at some point here will have to be dealing with this. So this has been really good.
Okay.
So thank you for that.
Yeah. No
Vaishak
problem.
and I are off to an hour-long meeting with IDEM, and I definitely need to caffeine up before a meeting. So,
All right, good. Yeah, I'll send out a link to the video once I've got the video.
Awesome.
And it's probably only another 5 or 10 minutes.
great. Thanks very much.
So I built the tail server. So I run the tail server the same way. I just say manage start logs, and it starts the tail server. And then when I run the demo, I just need to say revocation. So if I say minus revocation, then it will automatically build the credential definition with revocation support. And when it will issue a credential, it will issue revocable credentials and then allow me to revoke them. So if I start favor with revocation, and I'll just show you as favor starts up some of the things that it's doing. We've tried to make this seamless and efficient, but there should be, if you look in these parameters somewhere in here, there's a parameter that specifies where the tail server is. I don't want to look for it. This is buried in there somewhere. There's no difference with the schema. There's the credential definition that identifies whether it's revocable or not the schema. So potentially you could have credentials issued against the same schema that where some of them are revocable and some of them aren't. But you can see here in the log file is creating a revocation registry. And when we start up Aca-py, when we create a revocable credential, we actually create 2 revocation registries. So we've got one that's active and then we've got a spare. So when we fill up the first revocation registry and we start using the second one, there's no delay. When we start using the second one, then we kick off a process that automatically creates a third one. So we've always got one active revocation registry and one kind of pending that we're waiting for. And that's just for efficiency in managing revocable credentials. So I'll start with Alice. Alice, I don't need to do anything different. Alice receives the credential. Alice doesn't have any choice over whether she wants a revocable credential or not. She gets whatever Faber wants to give her, essentially. But I'll grab the invitation to set up the connection between Alice and Faber. Excuse me. I had COVID last week. I'm still recovering.
Oh man.
I'm real. Sorry here.
Yeah, it wasn't too bad of a case, but I found just the sore throat and the fatigue is hard to get over. Anyway, so now when I issue a credential, so if I issue a credential, comes back, it gives me these 2 extra pieces of information here. The revocation registry ID and the credential revocation ID. So these are the 2, if I want to revoke the credential, those are the 2 things that I need. If I ask for a proof request right now, then Alice can present. Alice just has the 1 credential, so she presents and I get the proof verifies equals true. And on the Alice side, we can see that she's done her presentation. If I revoke the credential, which is option 5, so it's asking me for the revocation registry ID. And again, this is what you provide when you call the API. Index 1. It asks me if I want to publish it right away. So when you revoke something, it publishes a record to the ledger. It publishes a new accumulator for the revocation registry. You can publish it each time you revoke a credential, or you can batch them. If you decide to batch them, like for example, if you do, like if you've got, for example, a nightly process that can expire a whole bunch of organizations and you want to revoke the credentials, but you just want to publish 1 record to the ledger, then you can just say, don't publish immediate, but wait until you've revoked a bunch and then publish 1 record, or you can publish them immediately. So you've got a choice about how you want to actually publish the information. I don't think Alice, in this demo, I don't think Alice gets a notification. But now when we ask for a proof, now Alice has a revoked credential. If Alice tries to provide that as a proof, then now the proof doesn't validate. So you get the proof validation as false because now the only credential that Alice has is a revoked credential. So she can't use it as part of a presentation.
So what would happen in the Trinsic app if you revoke someone's credentials?
I think intrinsic, it will show a notification to say that they've got the credentials being revoked.
Okay.
So
then,
it would show up as a status that says revoked, and I'm not sure if it would allow them to present it or not, or
Yep.
they would just warn them and still allow them to present it. That's again where you'll get different behavior between different mobile apps.
yeah. And then I guess like they'd have to start the proof process all over again if they wanted to use the system again.
They'll they'll need to get a new credential.
Yeah. Okay.
They'll still have. So the way it works with the lawyers is they've got a reissue process where the lawyer can request that they get the credential reissued.
Yeah.
For whatever reason. Maybe you're familiar with it. So it does a revoke and a reissue kind of as one operation or one user operation. So the user clicks on reissue and then their agent will revoke the credential and then reissue a new one.
Oh, okay.
But the connection, that's where in this use case, if you're storing the connection to the holder agent, then you don't need to reconnect to the holder agent. You can just revoke an issue without having to, explicitly open a new connection to their agent.
Cool.
Cool. Okay. So that's the end of the demo, and I've got some links here with just the flow and the wireframe that was shared with me last week or earlier this week, I guess. And there's an existing demo that I don't know if you guys have seen or not, but anyway, the links are there for you. So I guess I'll leave it up to you guys. If you have any questions, what I'll do is I'll re-email a link to this this document, and I'll include my contact info on Discord. I don't know if you guys are connected to Discord, but there's a whole bunch of Hyperledger Aries channels on Discord that you can ask questions of. It's a good place to go because then you get someone other than me. But if you want to ask questions to me, then you can either connect with me on Discord or just send me an email, and I'll keep track of that. And if there's any follow-up sessions that anyone wants to go into any of this stuff in more detail, then just let me know.
Sounds good. Thank you for your time today.
My pleasure.
Yeah.
All right.
Yeah,
Thanks
thank
a
you.
lot.
That was
Okay,
good.
That's
Thanks.
great.